Hey everybody, it's been a little while since we've had video. Today we're going to be talking about conic sections. So before we start talking about any specific conic sections, we need to know what a conic section is. Well, a conic section has to do with two infinite cones. So what we mean by these infinite cones is we got this cone is going to extend forever. We show it here because that's what we can actually fit in a drawing, but that cone would extend on forever. So we've got two infinite cones that meet at their vertex. So that's kind of the key of what conic sections are based around. So that's what a conic is. And then our conic section is a plane. Remember, a plane is a flat surface that continues on forever. A plane that comes through and intersects our conic in some way. And what happens, depending on how that plane intersects our conic, is going to determine what kind of a result we get. So right here we're looking at this yellow component here that is the intersection of our plane and our conic, because our cones and our conic are actually hollow. So we end up with this yellow shape here, which if you look at it closely, it might look familiar. It's a parabola. So our first conic section that we need to talk about is a parabola. Now, I know a fair amount about parabolas. Some things that we know about parabolas is, well, we know that they have a vertex. We'll talk a little bit more about that. They have an axis of symmetry. They come from quadratic equations, meaning that we've got an x squared variable in that, and y is not squared. So maybe something like y equals 5x squared plus 2x minus 3. That would be a standard form. Talking about review here, standard form for quadratic. Or since we're talking about parabolas, we may use what we call vertex form, or completed square form. If we think back to when we talked about those, I like to call it vertex form because y equals a times x minus h squared plus k helps me very easily find my vertex of that quadratic, of that parabola. Remember, our vertex was h comma k. A was either a stretch or a compression. And if A was positive, it opened up, the parabola opened up. But if A was negative, it was going to open down. So that's just kind of a quick recap of some of the things that we already knew about parabolas and just maybe needed to refresh our memory on. But today we're going to talk a little bit more about what the actual definition of a parabola is. So a parabola is a set of points in a plane equidistant from a line M and a point F on the same plane. So what that means, and there's a nice Khan Academy video attached to this post in Google Classroom also that kind of goes through the same process. They explain it a little differently, very detailed explanation that they have. But what we've got is we've got some line in our plane. My computer screen is going to be my plane for this. And I've got some point that's not on the line. And the parabola is the collection of points separate from those two that are the same distance from the line as they are from the point. So here, if I think of this point, by the way, this point is known as the focus of our parabola, and this line is known as the directrix. Now, easiest one, well, if I were to connect these two and find the midpoint, that's going to be a point on my parabola. But then I want to keep that same distance between, remember, my equidistant from my point and from my line. Now, as I go to the right, I'm getting further away from my point, not further away from my line, so it starts to, that point starts to pull it up, that focus starts to pull it up. And the further I go to the right, the further my focus kind of pulls that up and away from that line. And, well, I know that if I go to the left, it's going to kind of follow the same pattern, which means that my parabola should have symmetry. And my drawing here is not real great, but if I pick any point on that parabola, it would be connected because it's a continuous function. But if I pick any point on this parabola, this pinkish purple line should be the same length as this red line because it's the same distance. Let's call that D and D. It's equal. Oh, I'm sorry, I put my purple point line in the wrong spot. Let's fix that. From our focus, not from our vertex. So these two sections should be the same length. Oops. I don't know why that happened. Apparently I didn't have my pen tool selected. So this line segment should be the same length as this line segment. Yeah, my drawing's not great, but that's really what we end up with. The definition of a parabola is that those distances should be the same. The distance from the line, and we always measure distances from the line, perpendicular to the line. So the distance from the directrix, perpendicular to the directrix, should be the same as the distance from that point to the focus, or from the focus to that point. Alright, breaking down some of the points of our parabola. Okay, some of these we already know. Well, our focus, there it is right there. We know our directrix, we've got our line in there, our directrix. This point at the bottom, hopefully you remember back from the bottom of our parabola, the medium of our parabola, in this case since our parabola opens up, hopefully you remember back from when we talked about parabola, so that's our vertex. And then we've also got this other vertical line right here. That isn't really part of the graph, but we know that these parabolas have symmetry, so it breaks them up into two parts called our axis of symmetry. So we've got our axis of symmetry. Everything on the right side of our axis of symmetry is going to be congruent to everything on our left side. So everything over here is going to be congruent to everything over here. And that's how we talk about our axis of symmetry. Alright, so equations of parabolas. We already said that equations come from quadratics, but why do they come from quadratics? Well, it has to do with our distances, and I'm not going to get into a lot of detail on this one. That Khan Academy video that I mentioned earlier does a great job of showing how the equation of parabolas actually come about using the distance formula, which our distance formula, the distance between any 2 points, is the square root. Distance is equal to the square root of x1 minus x2 squared plus y1 minus y2, that's difference squared. Oops. I got the wrong kind of pen there. I apologize for that. Let's do that again. Probably don't want yellow. So x1 minus x2 difference squared plus y1 minus y2 difference squared, and those points are x1, y1 would be 1 point, x2, y2 would be the second point that we're finding the distance from, because you will need your distance formula today on your assignment. Okay, so how can we find the equation given a focus and a directrix? Well, that's our challenge for the day. So if I give you the focus and I give you the directrix, we need to be able to apply that distance formula to that. Okay, so let's say I have a focus. We'll make it nice, easy one here. Let's say I had a focus of 2, 3. Not too easy because we don't want it to be too boring. We don't want too much symmetry. So here's my focus. And as an example, let's say I had a directrix of y equals, directrix is going to be horizontal in this case, y equals -3. Now the first thing that I notice is my directrix is below my focus. So if I think of what these would look like on a graph, my directrix is going to be down here, my focus is going to be up here, so my parabola should open up. Okay, so we were just talking about how we knew that this graph opened up because our directrix is below a focus. So if I would draw a parabola in there, somewhere in between, rough sketch, my parabola would look something like this. Okay, so I need to try to find the equation for my parabola. Well, I know that any point on my parabola has to have the same distance to my focus as to my directrix. So all I'm going to do is I'm going to use the distance formula. I'm just going to call this point right now x, y, because I don't really know what the coordinates of that point is. So I'm going to find the distance from x, y, point on my parabola, to the focus, which was 2, 3, if I remember correct. Let's double check that. Okay, distance formula, square root of my first point, I'll use this one. I changed my mind. I want to use that one first. I'm going to use my x comma y first. That's going to work out nicer for us later, so let's stick with that. So x, y, the second point, 2, 3. And I almost forgot my square there on my second parenthesis. Okay, so I know that distance should be equal to the distance from my point of my parabola to my directrix. My directrix is y equals, I believe it was -3, but let's just double check that. Yep. Now, I'm going to go back to my drawing here real quick. And I've got to remember, back to geometry, the shortest distance between a point and a line had to be perpendicular to that line. Well, if this is a horizontal line, and I'm perpendicular to it, I must be vertical, which means that this point on my directrix has to have the same x value as the point that I'm measuring to on my parabola. So the point here that I'm measuring from has to be x, comma, -3. So I'll go ahead and put those under my distance formula. First point, x, I better leave myself some room there. Y, second point, right here, x, -3. Okay, now I'm going to go ahead and I'm going to try to simplify this equation and see what I can find out. First thing I'm going to do is I'm going to square both sides so that I can get rid of those square roots. So they're gone. Looks like I get x minus 2 squared plus y minus 3, that quantity squared, equals x minus x is just 0 squared plus, I'm going to simplify that and say minus a -3, we're going to put plus 3 squared. Alright, so I've got these y's on both sides. I'm hoping that this comes out to be quadratic with an x squared, not a y squared. So I'm going to leave x alone. And I'm going to get y outside of parentheses. So x minus 2 different squared plus, if I remember my real square double square, otherwise I can write it y minus 3 times y minus 3 and 4. I'm going to jump to my square double square. Equals, well, 0 squared, that's just 0. I'm not going to worry about that. Y plus 6y plus 9. Now, kind of a coincidence here. It is very much a coincidence because of the way I selected my points of my vertex, my focus and directrix, that these two come out to be the same. So I'm going to go ahead and I'm going to keep simplifying this. I missed my square there. I'm going to subtract y squared from both sides. X minus 2 squared minus 6y plus 9 equals 6y plus 9. And from there I'm going to keep going until I get y by itself.
Sometimes when I hear some music gossip, I will just kind of let my friends know that I don't listen to those things, but it's going to be someone else always doesn't listen. But online, writing classes completely go out of hand. When your friends study off the marathon and your friends go marathon, well,